I'm Dave Kassler, amateur radio, call sign KE0OG. I have a small confession to make. You see, I've not recommended linear amplifiers in the past and had no intention of getting one because of the expense. Plus, an amplifier helps my outgoing signal but doesn't do a thing to improve reception. But then one fell in my lap. So, let's talk about how I added an amplifier to my HF station. The amp in question is an old Ameritron ALS-500M, a 600-watt linear amplifier designed for HF mobile use and not necessarily intended for home station use. Now, mind you, an amplifier doesn't improve reception one bit. One would normally want to go to a gain antenna first, hard to do on 40 meters, my favorite band, where most people have dipoles or, like me, a vertical. But it is certainly possible on 20 meters to put up a gain antenna, my other favorite band. And anyway, 600 watts adds at most a couple S units or so. At one point, some years ago, I'd looked at costs for a tower, but quickly got past $10,000 even for a simple system with a simple beam on 20 meters. So I put the idea on a back shelf and continued to operate barefoot, meaning without an amplifier from my 100-watt HF signal. Then I got a call out of the blue from an elderly ham friend. He had an amp that had been sitting in a box in his garage for over 20 years. Would I be interested, he asked. The price was low, certainly much less than for a new one, so I picked it up, not really knowing if it worked. I did some tests and found that I'd gotten a real bargain. Even with its age, its performance is spectacular. He also gave me a very nice watt meter to go with it. Okay, so here's some info on the amplifier. Over the past couple decades, Ameritron, now a subsidiary of MFJ, continued to improve the amplifier and add bells and whistles, even though the model number was never changed. Even the looks changed. On top is a picture of Ameritron's current offering, and below is a photo of my amp. You can see significant layout differences. One feature included even in my early amp, the actual power output stage is composed of 4 transistors with no tuning required across a given band, though you do have to set the band. The new model will communicate with your radio to know which band to use, but that mod came long after my amp was manufactured. Note that because the amplifier was designed for use in a mobile environment, it has to be able to withstand a wide range of input voltages. It says that it can run even up to 16 volts. In fact, the manual is quite proud of this fact. It goes on to say that below 14 volts it loses 85 watts per volt. Clearly, there's an incentive to run it at as high a voltage as possible within its limitations. In a mobile environment, given the current draw of up to 80 amps, extraordinary efforts were required to keep voltage drops to a minimum. Dick did this in his vehicle with thick, fat welding cable, so the voltage drop from the battery would be manageable. Okay, let's take a look at what's inside here. This is the front of the Ameritron, load fault, thermal overload, the frequency switch. It doesn't go by band, it goes by what range of frequencies it covers, and a simple on-off switch. The DC amp switch is utterly undamped, so it just flings around as you talk. So over here there's an outlet or inlet, and over here input for the heat. On the back we have this huge power plug, this giant Jones plug kind of thing with 2 large poles to make sure it lines up right. The relay is the push-to-talk from the transmitter. The RF out here goes to the antenna. RF in comes from the radio. And there is, of course, a ground lug over here. This was built a long time ago. It's an older model here. So let's see what it looks like inside. Okay. The first thing we're faced with is this gigantic heatsink over here that goes all the way under here, and this little fan moves the air so that it goes by the heatsink. The actual guts of the device are these transistors, the Toshiba 2SC2879. There's one there and one there that's got a temperature sensor on it. And then here's the other half with a temperature sensor and another one right there. That's where the grunt work is done. Okay, look at all these banks of resistors to get enough power in there. This is a linear amplifier, so it's going to be not terribly efficient. Here is the relay for transmit and receive. Some huge coils over here that are part of the band switching. Interesting, this is the knob that turns it, but the contacts themselves are not exposed. They're inside there. I suspect that keeps them working better. This is to keep the input from the radio tuned to the input of the amplifier. There's space here, extra space here, to put the coils for 10 and 12 meters. For a long time, the FCC would not permit any amplifier sold to work on 10 or 12 meters because they were afraid that the 11-meter CB guys would use them. That hasn't stopped them, of course. Here's a little bit of the control circuitry right here. There's even an IC in there, like that. A little things for adjustment, which I am not going to even come close to touching. And the control board there, this is the DC board coming in, some small components in there. It almost seems a little out of place to see these dinky little components inside such a transceiver. So the power comes in here. The two wires are hooked across here, and it comes up as 2, measures the current through. And then the wires come up over here where they go into the main amplifier board to be used by the two sides. It's push-pull, so one side hits, then the other side hits, then one side hits, then the other side hits to construct the output waveform. It's big, it's hefty, it's strong, and considering it's been in a box for 20 years, it's remarkably clean inside. I thought perhaps I'd come in here and need to blow out a bunch of dust, but that's not true. So, that's the inside of the Ameritron ALS-500M. Now, I'm not operating it in a vehicle, but in my home station. As it turns out, MFJ makes a switching power supply that looks like a good match, the MFJ-4275MV. The M means meters built in, and the V means a variable output voltage. The website even says it's the perfect companion for the ALS-500M. They don't, however, reconcile the 4275's 75 amp max with the amp's need for 80 amps max, but that hasn't been a problem for me. Interestingly, the 4275 will put out full current even when set to 16 volts. So that's putting out 1200 watts of power for the amp's use. Given normal power supply inefficiencies, it will probably draw 1300 watts on transmit peaks. Yes, it dims the lights. A 75 amp power supply has to be hefty, and it is, as these pictures show. Now I'm going to try something I haven't done before. Let's see what is inside a 75 amp switching power supply. It's got all sorts of outlets on it. Here's a cigarette lighter type plug here, up to 10 amps max. We've got these little things here, power pole connectors for up to 35 amps. You can do 10 amps max on each one of these, 40 amps on these, and these are the big ones here. 75 amps through those two connectors. 70 amps continuous, 75 amp peak. Wow, that's big. Okay, I've taken all the screws off. Let's see what's inside. The first thing that strikes you is these heat sinks. They're enormous. I mean, just put a finger on here so you can get a size. And they're really, really tall. So there's 1, 2, 3, 4 of these for the main transistors. Now take a look at these capacitors over here. These capacitors are a millifarad each. That's 4 millifarads. That is incredible amount of capacitance. And it looks like this right here is the controller board, and there's some stuff tucked down underneath here, and then they've got they're just inductors down in there. Okay, notice the what it goes through to rectify the input current. Look at all those diodes in parallel, and here come all these resistors in parallel. It's just phenomenal what we're looking at here. Now it's interesting, this connector back here on the back is billed as a battery charger. Okay, so you can use a battery there. There are 2 fans, and the normal computer type power input, and an on-off switch that's pretty good sized there. Okay, we've got toroids up on this little circuit board, and down here a bunch of connectors. And if we look at it from the other side, here we see some big toroids. Okay, by big, here I'll just put my finger in. Watch, they're huge. Now note that to the main connectors down here, you'll see that there are 4 black wires and 4 red wires going to these front connectors. These front connectors are huge. If you take one of these off, you see that we're dealing with a great big screw. We just keep screwing and screwing and screwing here. It's very solid. You see that, very solid copper, and a lot of capability right in there, so to handle that 75 amps. Okay, there's a little circuit right here mounted to the heat sink to detect over temperature on the heat sinks, and it protects the power supply. More capacitors back here. This is an amazing essay in the engineering of size into a fairly small package, considering what it's doing down in here. It's just plain heavy duty. And in a tip of the hat to my wife, she bought the power supply for me as a gift. Given that I need to change the band switch manually, the amp has to go somewhere very near my operating position. I also need to be able to turn the power supply and the amp on and off. The ideal spot is next to my desk, so I put in a shelf, as you can see here. Although the weight isn't tremendous, it's still significant, so I built the shelf to handle lots of weight. Instead of screws in the load-carrying positions, I used through-hole bolts. Hopefully, it's not going anywhere. From this position, I can easily turn the power supply and amp on and off, as well as conveniently change the band switch. Now, most providers will provide a feedback signal to the transceiver called the automatic level control, which will reduce the rig's power output so as to avoid overdriving the amplifier. Curiously, the ALS-500M has no such output. So I did some experiments and found that if I turned up the transmitter beyond 62 watts, I'd get no further amplifier output. So that's where I run the FTDX 3000, and it seems to work very well. But note that a push-to-talk connection is required. The amp seems quite linear, and I get excellent audio reports. I should point out that none of my antenna tuners will handle this level of power. So, last November, my wife and I thoroughly tuned my Butternut HF9V multiband vertical antenna to get the SWR down well below 2:1 nearly every place I want to operate. That way the ALS-500M can feed directly into the antenna, and I don't have to worry about tuning. Once set up, operating is a breeze. I just turn on the power supply, then switch on the amp, then switch it to the right band, and after that, I'm never even conscious that it's there. As far as how it affects my on-the-air experience, I find it's a lot easier to get answers to my CQs. However, sometimes it's hard to hear those who return my call, again because the amp doesn't help me hear better. Oh, and it's a bit easier to break pileups during contests and DXing, but it's not in the same league as the expensive 1.5 kilowatt amps and the big beams that some hams have. And I'm quite pleased to report I have no RFI issues in the shack. I recognize there's a bit of irony here. I've made several videos about the BITX40 QRP rig, and we'll make a few more. And yet, here I am talking about an amp that's 100 times the power, or 20 dB stronger, which is over 3 S units. Well, yeah, okay. And I'll admit I switched on my amp during the recent ARRLDX contest. But both aspects of the hobby, QRP, or low power, or QRO, or high power, are part of the hobby. I still say that if you're new to HF, you shouldn't start with an amp, but you shouldn't start with QRP either. I think 100 watts and a wire antenna is a great place to start. But as you get more into HF, it might be something to look into. It only took me 40 years to get one, and that only because it fell in my lap. Thanks for hearing my little confession. The fact is, I'm quite delighted with it. Thanks so much for watching. Please click like and please subscribe. Check out the Ask Dave playlist and the tip jar. Use both feet when walking. Leave a comment. Ask a question. Until next time, 73.